Let's walk through the process of troubleshooting, diagnosing, and repairing this iPhone XR that appears to not turn on. So one of the first things I like to do is check the USB meter. This tells us how much current is being pulled by the phone into the charging circuit, and a phone that does not charge typically means it's not turning on. So in this case, we're getting 0.439 amps. Typically, working phone will give us 1 amp or higher. So for example, here's my iPhone 7 Plus, and you can see it is charging at 1.2 amps, 1.3 amps. It might even go higher. It all depends on the battery, but in general, above 1 amp. And this is kind of what it looks like. But if I plug in the device that we're trying to fix, you can see we're actually getting 70 milliamps. And then I've noticed it actually jumps up back to 0.43-ish amps. There it goes. 0.439 amps, basically 0.44 amps. One of the things that I've noticed is when you get a 0.43 or 0.44 amps on your USB meter, it could be that the device is in DFU mode. So one way to test that is plug in the phone to the computer, and I heard a chime by the computer. So here we can see it is detected by 3U Tools in DFU mode. 3U Tools is a more advanced kind of iTunes tool where it allows you to do all kinds of stuff, including updating, restoring, backing up, and some other stuff. But I use this as my main program for working on these phones, and you can see the tool detects the phone as DFU mode. So if you go to Smart Flash or you click Go Flash, you'll see we can flash the 2 different iOS versions available right now. So one of the common failures on iPhone XR when it's spontaneously in DFU mode for no reason is there's a resistor that goes bad that causes the phone to, for whatever reason, to be in DFU mode. So if you were to flash this, either do an update or restore, you will end up back in DFU mode. Now, this issue is also kind of intermittent. As I was about to record this, the phone was actually booting up again on its own. I didn't do anything, and then I unplugged it, plugged it back in, and it's back to DFU mode. So that could be another symptom where it's sometimes turning on, sometimes it's black screen, but right now I also see no backlight. So that's also another thing to look out for is on the phone itself. If you have no backlight at all, that could be that it's in DFU mode. If you get a backlight but no image, that's also a symptom of possible DFU mode. It kind of varies. I've seen both scenarios. Like right now, there's no backlight. Best way to see it is, turn off the lights and see if you see a glow. Or if you have the phone open, look at the side of the frame. Now this trick only works on LCD phones, not OLED phones. So a phone with OLED, you will not see a backlight no matter what because there's no backlight on those. One of the things about DFU mode also is you cannot exit DFU mode. You have to restart the phone and hope that gets it out of DFU mode. If you cannot get it out of DFU mode manually by unplugging the battery and plugging it back in, force restarting it, what you can do is flash the device. So here on 3U Tools, you go to Go Flash. At the bottom, there's 2 options: retain user data and quick flash. Retain user data will update the software, but does not touch the user data. So like pictures, videos, contacts, all your stuff will still be there. If you do a quick flash, that's a restore. That will wipe all your data. That's a factory reset, basically. Another thing to be aware of is here on the upper left, there's Easy Flash and then there's iTunes Flash. Easy Flash is the 3U Tools way of flashing the device. iTunes Flash, it mimics iTunes. So if you get an iTunes error code, it is best to use iTunes Flash to see what the error code. Because Easy Flash also gives you error codes, but they're never the same as an iTunes error code. So when in doubt, do both if you're trying to troubleshoot an issue as to why. If you're trying to troubleshoot an issue where it's stuck in DFU mode or recovery mode. Recovery mode is kind of the same in that you're stuck in this mode where you have to flash it, but recovery mode does give you an option to exit recovery mode on here. This one just tells you to manually do it. So now let's go ahead and open up this phone and let me show you the most common fault in this type of behavior. So now I'm going to open up this phone and I'm going to show you also a very important step in troubleshooting and diagnosing board level issues. One thing that I do see a lot of technicians skip is using a DC power supply to diagnose no power. This is a very important step because it tells you a lot more as to what the device is doing versus a USB meter. This only tells you what the charging circuit is doing or USB communication is doing. This tells you what the phone is doing, like the whole thing. So what I'm gonna do is, this is a DT880, it's no longer in production, but I do have other videos on my channel where I show different DC power supply boot cables. This one is very convenient, and I have plugged in, I'm actually using the iPhone X plug that I cut just the battery connector, and then if you plug it in this way, you will get basically a connector for the XR. So I'm gonna push power. So one of the key things here is we see no current draw before prompt to boot, and then I'm gonna do a prompt to boot using the power button. I'm holding it, and you can see it is only at 68 milliamps or 69 milliamps, basically 0.069 amps. So what that means is that it's trying to boot and then it just stops. And usually this type of behavior implies DFU mode. So learning kind of the different patterns about what happens when you prompt to boot can tell you a lot, because there seems to be certain patterns mean certain things, and you can't really tell that with the USB meter. Best to do a DC power supply connected to the battery connector, because when you prompt to boot, you're now replacing the battery with the meter, and then you can monitor what the board is trying to do. So this is a key sign that you're in DFU mode. It's not always, but a good percentage of cases where you get like 68-ish milliamps when you prompt to boot usually implies DFU mode. And the best way to test is plug in the charging cable and listen for that chime. And then you can use 3U tools to check to see what is it being detected as. All right, so now I have the board out of the housing, and we're just gonna do a quick inspection just to check for any water damage, any issues like a cracked board or cracked ICs or any dents, anything that will warn you like, hey, be careful, keep an eye out for, because sometimes you can run into unknown issues, and seeing the condition first, doing a visual inspection is key. There's so many cases that I ran into where just a simple visual inspection has helped me solve the problem. As of right now, I don't see any major issues. Everything looks normal, no dents. The NAND doesn't look cracked. This all looks typical. So that does come with experience. So something to keep in mind is when you're picking a board level tech, pick someone who has years of experience, because when you have years of experience, you've seen a lot of things. And so far, everything that I've seen looks normal. Now, for this specific scenario, I did write about this solution on the repair wiki. So you should check it out as repair.wiki, and you want to search for the iPhone XR page. So basically the fault is in this area. So the NAND, this is the storage chip, the memory chip, whatever you want to call it. On this corner, there's a resistor that either gets loose or broken. So let's clear out this underfill. So I'm going to use about 250 Celsius on my hot air station. This is just enough heat to soften this underfill. It's kind of like a rubbery substance that coats all the components. I don't know exactly what it does, but it is there, and you got to clear it out. Maybe for water resistance, shock absorption, I don't know. You guys let me know in the comments what you know about this. But I'm using an number 11 scalpel blade and a very sturdy scalpel handle. So I'll link to all my tools in the video description below. And you gotta be real careful, because like I said, there's a loose resistor here. Oh, it just went flying. I just saw it. So let me clear out this general area. So you can see there's components here that were coated or covered, so you couldn't see it. But let's kind of clear this out. And there you go. So you can see there's supposed to be a resistor here, and it actually just went flying, and I lost it. So let's take a look at ZXW to see what that is. All right, so this is ZXW. It's a board view software. It lets you see the layout of the motherboard, all the components, how they're connected to each other, and the failure that causes an iPhone XR specifically. I haven't seen it on any other model. I believe I had a friend who had similar issue, same resistor on a different model, but that was like a specific case of like water damage or hard drop or something. I don't remember. But XR specifically is a common fault, signature fault, whatever you want to call it, is R0601. This resistor will come loose or break. Sometimes it's still attached to the board, but you got to poke it and then you'll see it crumbles or it cracks in between. And I think it's just based on the location on the board. You know, as the board kind of bends, it might just damage the resistor. This resistor is the PP1V8IO to SPI AP to S4E MOSI boot config 1. I don't know what that means, but if you click on it, you can see it has to do with something with NAND. On this side is the power source for the circuit or for this line. So basically 1.8 volts goes into the NAND at this point for whatever reason, and it does something. The real question is, what is the value of this resistor? Now ZXW unfortunately does not have component values for the XR, but let's take a look at JCID Drawing. This is a different board view software made by JC. You know, if you're familiar with their tools, they also make a software. So let me rotate this to match. And here's the resistor R0601. We click on it. It does have a, wait, I don't know if you guys can see, but it does have schematics built in. So on the left side is board view. A lot of people wrongfully call this schematics. This is schematics. This is like the electronic layouts, kind of like how things are wired together. And then the board view is more of a physical layout. So this is the electrical layout and this is the physical layout. So if we go to this resistor and we click on it, according to the schematic, this resistor is a 4.7K ohm resistor. So we need to source this because the one on this board went flying and I need to find a replacement. Tricky part is how to find a replacement. I wonder, let's try this search, 4.7K. All right, well, I guess that search doesn't work. All right, let me just grab a donor and we'll take a look. So the easiest way to find a replacement would be to grab a donor and get that exact same component and transfer it over. But if you don't have that donor, what you can do is, for example, on ZXW, there's a feature here called part BOM information and related query. So pretty much pull that up. Now ZXW, for whatever reason, does not have component values from, I think, like 10s and newer. So you can only search basically iPhone 10 and older. So what I'm gonna do is I'm gonna search, we need a 4.7K ohm resistor. So I'm gonna put 4.7K, kind of generic terms because I don't wanna be too specific because the search function is probably not that great. So very specific where it won't confuse the software. And here you see a list of models. Basically the models and their components that are 4.7K. Now, because my screen is 4K and ZXW is not properly coded, they didn't program this properly. The text is really tiny, but I can see here, actually let's do this. Let me screenshot and zoom in so you can see a little better. All right, so this is kind of what it looks like. You'll have the keyword where I search 4.7 and click search, and then it just gives me a list of all the models. So S7 Edge, I'm not gonna do that. iPhone X Qualcomm, there's 4 resistors here. Oh look, it has the same one. 4.7K is the value, and this is really what we want, 01005. So that is the size of the component. And if you remember the schematic, it actually gives you all this information as well. So this is probably gonna be the same one because look, it's the same code as well. That's just coincidence, and it's not always the same. But if you scroll down, let's see, iPhone 8 Plus, 7 Plus, 7, 6S Plus. they all have a few of these resistors. So let me grab one of these donors, and then whatever is the easiest one to find near me, I'll use that. All right, so I found an iPhone 8 Plus here that I can use as a donor. So the iPhone 8 Plus I have is a Qualcomm, Intel, but the one on here says QCOM, which is Qualcomm. So let me keep looking. So this is the fun part where I have to dig through donor boards. I have a lot more donors, but these are most recent ones I've used. All right, well, I found an iPhone X. Now I don't know if it's Intel or Qualcomm, so I'll basically just have to, let's just assume it's Qualcomm, and then we'll see what happens. So iPhone X Core, let's just get the same one. So what I'm gonna do is I'm gonna click that one. ZXW is gonna open up that board view, and it's literally gonna drop me on that component. So if I click on it again, it's telling me where it's at. So there you go. This resistor here is the compatible one. Looks like it's just gonna be this one here. According to ZXW, the third one after this cap, 1, 2, 3, this is what I need to take from this board and put it on the XR. So we're gonna do same thing as clear the underfill. Now, I don't know if you guys can notice, but we have a different texture to this underfill. It's like a little thicker, but it's still easy to manage. There's some other models that have really like rock hard underfill, and it's a nightmare trying to clear it out. So gonna be the third one, so let me clear in between. So I'm using 250 Celsius, 40% airflow to clear out underfill. This is hot enough to soften the underfill, but not melt any solder. So you're not gonna destroy anything in the process. Now what I'm gonna do is I'm gonna tin the solder joints, hopefully make it a little easier to remove. And then I need to grab this component off the board. And since this is a donor board, I don't really care what happens to the CPU, so I'm just gonna heat it without any heat sinks. This was a working board. Doing this is very dangerous because you can float the CPU and then you have bigger problems. So right now I'm just heating this at 380 and 50% airflow on my add-in hot air station, which is linked in the video description below. Don't forget to browse that video description because there's going to be a lot of useful tools in there and links. And if you need this repair or you need data recovery, reach out to me for a quote. Alright, so I got the component stuck on my tweezer. Now I gotta swap out the boards without losing the resistor. So I'm kind of doing it one-handed. You know what, I'll do this. I'll just lay it there. Now one mistake I did is I didn't prep the pads before, but that's where it goes. So maybe I'll put it there. And then let's take a look at these pads. Flux, very important. You should always be using flux when soldering, and good quality flux. Don't just grab whatever you find on Amazon. You're gonna have trouble soldering stuff. Essentially, I'm just rubbing some solder on there so I can install a lot easier. Now there's a few ways to do this. You can do hot air or iron. I like to do hot air. So what you can do is add a heat sink on the NAND and then come in with the same hot air as I removed it. Now this is a tiny component and none of the legs are on ground, so it will install pretty easily. Oh, it's kind of flying away. Oh, yeah. It's like a really tight spot actually. And the flux, because it's liquid, it's kind of sucking away the component. There you go. I kind of have it lined up, and then the surface tension will suck it into place. But I have my blade nearby so I could bump it into the right position. Once it melts, not sure why it's taking so long, but it should melt any second now. Come on, let's go. There's some underfill there as well. Alright, that felt like it was too long, so let me add some more flux. Let me try to feed it a little bit of solder from the tip of my iron. Alright, add some there. This top side might be hard to reach. All right, let's try it again. Let me rotate this as well. Maybe I'll have a better angle in here. There's a big blob of solder on that one end. Now what I can do as well is with my iron also supplement the heat. The hot air and iron, see if I could get it on those pads. So really, there it goes. Yeah, it should be good. Oh man, that took way more heat than I remember it taking. Hopefully, I'm hoping nothing floated. What that means is, since it's trapped in underfill, the gases from soldering and stuff create expansion and create problems. So the downside of working with underfill is you can cause additional problems somewhere else on the board. So you got to clear it. So the more beginner you are at this, the more underfill you should clear the nearby areas. Once you're like better at it, you kind of will tell when you're using too much heat. You'll have better control of your heat application onto the board, if that makes sense. So I got that installed. Now the poke test. Yeah, I'm poking it and it feels solid. We could also do a diode mode test. So essentially we're gonna just measure, oops, my probe slipped. So 261, 242. So yeah, I mean, it's not shorted and we get readings. So that means there's some connection somewhere. So I think we're good. Now we should go test. At this point, we're gonna do everything we've done already in the beginning. We're gonna just do it in reverse. So first, we're gonna use the DC power supply to see if I prompt to boot, do we get the same behavior where it would just jump to about 68 and just hang there. I'm gonna use the power button pin on the connector and just use my tweezers to mimic the power button. There it goes. Look at that, it's actually jumping around. Now I didn't hold it long enough. There it goes. So we got 72 now. And then, yeah, see it jumped over 100. We're getting a lot more activity out of the DC power supply. So it looks like it might be working. I'm just not timing the power button press correctly, but we are getting a big change on the DT80 behavior. So next, put into the housing and test to see if we get any signs of life. So right now I have everything plugged in. I'm gonna plug in the screen, ear speaker flex. Then at very last should be the battery. And then we're gonna check the USB charging current so we can see if anything has changed. All right, so if you remember before, it would hang at 70 and then jump up to 0.4 something. And What do we get? What do we get? Oh, we got Apple logo, and look at the charging current. We're now at 1.7-ish amps as far as USB charging current, and we're getting signs of life. So now we gotta wait to see if it boots, see if there's any other issues, and if it's all good, then we're gonna have a happy customer. We'll be able to back up their data and be able to share that with them. So let's see what happens. Let's see if we had a successful repair. Now, one thing you might run into if you did flash an update, you might get a white screen that says press or swipe up to recover, and then you have to type in the PIN code, and you have to go to the data recovery attempt, or I think it says, or attempting to recover data. Now, I don't know if this one specifically has been updated. I didn't actually flash an update just because I right away detected all the symptoms of that resistor being bad. So I just held off and I checked the resistor, and sure enough, it was loose. So decided to make a video on it and show you guys kind of that whole process. Now, it is stuck on the Apple logo, so it's not a good sign, but sometimes it just takes forever after it's been dead for a while. And sure enough, so it looks like someone did try and update it. So this is the screen. So you have a swipe up to upgrade, I guess, I don't know. The wording might change a little bit, but basically swipe up, the white screen. Oh, we got touch. And then when you swipe, oh, look at that. I just typed in the PIN code once. Usually it'll be twice, and then it has to go to the loading bar saying attempting data recovery. I just typed in the PIN code once in this case. So maybe when you get swipe up to upgrade, you only do it once and it goes right away. Usually when you update a phone, in whether it's like a big jump from one iOS version to another, or it had some weird issue and you had to flash an update to solve like a boot looping or stuck on Apple logo, then you might get to swipe to recover, and then you basically have to type in the PIN code twice, and it has to load the whole bar, and if at the end it detects the PIN code was incorrect, it'll kick you back to swipe up to recover. So at this point, let's wait it out, see what happens after this loading bar, and then I'll be right back. So basically, within a minute of thinking I was gonna sit here and wait for that thing to load, I just landed on the home screen. So I've now unlocked it. It seems to be working. I have T-Mobile LTE, Bluetooth, and Wi-Fi there. So I'm probably just gonna run some YouTube on it overnight, let it charge, and see if there's any issues with it. But as of right now, it looks like it's now working. And you guys saw that resistor just flew off the board, and basically, you know, that was a telltale sign that we have an issue with that resistor. So that one resistor can cause a whole phone to not boot up, get stuck in DFU mode. You know, you flash an update, it'll go all the way through and then come back to DFU mode. If you restore it, the exact same results. So hope you guys enjoyed the video. If you guys learned something today, let me know down below in the comments. I like to hear you guys' feedback, what you learned, what you liked about the video. If you have any questions about any tools that I used, let me know. I look forward to hearing from you guys. Check out my t-shirts, which are like this one, I fix phones all day. That's a great way to support the channel. I have my locals community as well, which you can follow me on there. I post a lot of useful stuff. I like to post different panic log solutions I discover. Like I mentioned, this is documented in the repair wiki as far as the troubleshooting steps, so check that out, repair.wiki. Just search iPhone XR in the search bar. And of course, we do have a course. We have two courses, a beginner course and a full-fledged 90-day solder course, so check those out. Both of them are linked down below. So I hope to see you guys there. Thanks everyone for watching. If you want to see another video, I will link it right here down below. And thanks everyone. I'll see you guys next time.